Alright, so in the last video, I kinda bit my tongue before recording it. It was a long story. So I might have sounded weird, or it's just the microphone not being of very high quality, because this is a laptop microphone I'm using. Don't expect us to have the best microphone quality. But we are still providing free physics knowledge. Anyways, today we're going to get into velocity and speed. So if you're looking for how to read velocity versus time graphs, this is not the right video. There should be a different video on that at some point. So velocity is defined as the rate of change of position. It's basically speed, but it has direction. And we call velocity a vector. So it has magnitude, which is speed, and then the direction. So in that case, if a person was traveling at 5 meters per second in the positive direction, then their velocity is 5 meters per second in the positive direction. I think I mentioned this in the last video, but I didn't go over it. So how do you determine what's the positive direction? Well, it could be anything as long as you're consistent with what you name the positive direction and what you name the negative direction. So in most cases, right and up is typically named as the positive direction, and then left and down is typically named as the negative direction. And it really doesn't matter, as I said, as long as you stay consistent in your calculations or your interpretation of a graph. Anyways, so there's two types of velocity, instantaneous and average. So instantaneous is probably going to come up a lot more than average, because when you look at a problem, they're going to tell you that at time equals 1 second, this person was traveling 3 meters per second. And that's only at that one point in time. In the next second, they might be traveling at 4 meters per second, so their instantaneous velocity is now 4 meters per second. Then there's average velocity. So average velocity is total change of displacement over the total change of time. So let's say in our previous scenario, the person moved 8 meters in 2 seconds. Then their average velocity is going to be 4 meters per second. And then we have speed, which is basically velocity without direction, or it's also known as the magnitude of velocity. You're not going to see speed in any physics problems, if I'm being honest, because it's missing out on the direction part, which makes it pretty useless. Because if you think about it this way, let's say that a person was moving at 5 meters per second in a positive direction. If that person were to slow down to 4 meters per second but still continue in the same direction, speed has changed and so has velocity. So that means that acceleration has also changed, and we will get into acceleration in the future video. But if that person were to start moving at 5 meters per second in the negative direction, then speed hasn't changed, because speed is still 5 meters per second, but their velocity has changed, which means their acceleration has also changed. So that's why we don't use speed. Anyways, that wraps it up for this video.